We're asked to find the area enclosed by the graph of mod x plus mod y is equal to 1. How might you do this? Well, if you thought about maybe trying to integrate this, have a go and see what happens. Well, the main issue we're trying to integrate is we need to know the limits. And in this case, we don't have any information of what our limits would be. We don't have any idea of how we can find the area of this. So integration will be quite hard. So what would be another method to tackle this? Maybe considering a visual approach, and maybe trying to graph it, and maybe trying to work out the area graphically. Okay, so let's do that. So how would this graph look like? So what does mod x mean? Mod x is precisely x if x is bigger than 0, and minus x if x is less than 0. And mod y is defined similarly. So what can mod x plus mod y be? So in this case, for mod x we had two cases, and mod y we also had two cases. So now when we add these two together, we have four combinations, these two multiplied by these two. This gives us x bigger than 0 and y bigger than 0, which gives x plus y. And similarly, x bigger than 0, y less than 0, x negative and y positive, and finally x negative and y also negative. I'll label these four cases 1, 2, 3 and 4. So how do these cases look like on the graph? What area of the plane do each of these cases correspond to? Well, if you look at it, they're exactly different quadrants of the plane. Case 1 is the top right, case 2 is bottom right, case 3 is top left, and case 4 is bottom left. Okay, so now for each case, let's work out what the equation of our graph means. So for case 1, x is positive, so it's plus x, and y is positive, it's plus y. So x plus y is equal to 1, which means y is 1 minus x. And we can do the same thing for all four cases. Case 2 gives us that y is x minus 1. Case 3 is y is 1 plus x. And case 4 is y is minus x minus 1. So how does that look like on a graph? So for case 1, we're in this region, and y is 1 minus x. The graph is going to do something like this. And similarly, we can do the same thing for case 2, case 3, and case 4, which would give us a diagram which looks like this. And we should note that these intersections for these axes are all at 1, 1, minus 1, and minus 1. Okay, so what can you tell me about this shape? Well, it should be a square. And why is that? Because we know it should be a square if and only if these lines are perpendicular to each other. And how do we know that that is the case? Well, because all of these lines are of the form y equals plus or minus 1 plus or minus x. So they have gradient 1 or minus 1, which means they are perpendicular. Then therefore it's a square, and it's not going to be a rectangle because of the symmetry between all four of these cases. So what is the area of the square? That's precisely the length of the side length squared. And what is this side length? Well, if you notice that this length is 1, and this length is also 1. So by Pythagoras, this length is root 2. The area of the square is root 2 squared, which is 2. So the answer is C.